this lesson, solving two-step equations, builds on what we learned in the previous lesson, which was solving one-step equations. Having said that, none of your vocabulary words is brand new, but some of them do bear repeating. First, we have a verbal model, which we first introduced you to in the very, very beginning of the year. Basically what that is using words, phrases, and sentences and symbols to show an equation. Our next word is something which you hear me say all the time, equation. An equation is a mathematical sentence formed by putting two expressions on either side of an equal sign. And then third, inverse operations, which you know very well by now, are two operations that undo each other. Multiplication and division are inverse operations, so are addition and subtraction. Let's get started with the first of our 5 examples. Okay, solve the equation, check your solution, so that's why I wrote the problem twice. Now remember, everything that we're doing in this lesson today, you already know how to do. The difference between these equations that we're going to solve and the equations from the last lesson is that there is one extra step, one extra thing to do. Let's take a look. We're starting off with 2 equals 4m minus 30. And remember, we always have to remind ourselves of our goal, which is that we want to get this variable all by itself. Right now, the variable has 2 numbers with it. It has a coefficient of 4, and there's a constant of negative 30. We need to, one by one, get rid of each piece so that the variable can be alone. When we have a case of a coefficient and a constant, what we want to do is negate the constant first. Get rid of the negative 30. And we'll do that by applying inverse operations. And the inverse of subtraction is addition. And when we talk in terms of integers, what that means is putting a positive 30 on both sides to zero out the negative 30. So here we have our 2, and I am also writing a positive 30. Next, remember what we do is we copy this whole expression first, and then I'm going to put on my positive 30. What we have here, we have a 2 and a 30. Together they make positive 32. And then what happens over here? Our 4m comes right down, because we haven't done anything to that yet. And what we have here is a negative 30 and a positive 30. I'm going to circle them because they're like terms. And remember, whenever you have the same digits but opposite signs, they make a 0. Now we're going to simplify this side, and we have 32 equals 4m. So now we're down to only one number with the m, coefficient of 4. Right now the m is being multiplied by 4. The inverse operation of that is to divide both sides by 4. And we're going to show that as a fraction. And remember, the reason we do that, or what happens when we do that, is that the m gets a coefficient of 1, which you can call 1m, or just m, that's a matter of your preference. And 32 divided by 4 is 8. So our solution is that m equals 8. Now we go back to our directions. We have to check our solution. So what I'm going to do is rewrite our equation, but this time I'm going to substitute the solution m, the solution 8, for the variable m. So we have 2 equals 4 times 8, and then our negative 30. 2 equals 4 times 8 is 32, minus 30. This 2 stays the same. 32 minus 30 is 2. Our solution checks out. M does equal 8. Our second example is very similar, but if you notice here on the side, I wrote down a couple of steps just to have us remember, and it's a good reference for you. Definitely copy down these 2 steps. Let's look at our problem. 8 minus x divided by 7 equals negative 10. Remember, there are 2 things happening to the x. We want to isolate the x, get it by itself. But it's being kept company right now. It's being divided by a negative 7, and there's a positive 8 sitting there. Let's take a look at our steps. First thing we're going to do is negate the constant. And remember, this 8, this number that has no variable attached to it, that's our constant. Our constant is a positive 8, so what we need to do is put a negative 8 on both sides of this equation. First, we'll copy down the expression exactly the way that it's written, and then we apply our negative 8. We'll do the same thing on both sides. We'll bring down what we have, and then an additional negative 8. And then look what happens. We have a positive 8 and a negative 8, and they cancel each other out. And that leaves us with a negative x over 7. And then when we combine the negative 10 and the negative 8, we get negative 18. So we're halfway there. Right now, what we're left with is x is being divided by 7, and we have a negative 18. Now notice the fraction is negative. What we're going to do to save us a step later on is make this 7 the negative part. See, remember, when we have a fraction is a division problem, and when you're dividing a positive number and a negative number, you have a negative number as your quotient. So what we're going to do is look at this and say, well, x is being divided by a negative 7. The inverse operation, the way to undo that, is to multiply by a negative 7. So here is our x over negative 7. And as I said, we're going to multiply by negative 7. Since our first term is a fraction, I'm writing the negative 7 as a fraction. And now we bring down our negative 18, and we multiply that by negative 7. Since the 18 is not in fraction form, I'm not going to put the negative 7 in fraction form. Let's go back to the left. This negative 7 and negative 7 cross-simplify, and that leaves us with just x. And here a negative 18 times a negative 7 gives us a positive 126. And there's our solution. X equals a positive 126. Okay. Now our third. Here we have a verbal sentence, and you have to write it as an equation. We've done this before with expressions. So there's nothing here that you haven't done yet. We just have to go through the sentence, look for our clue words, and put it all together with the numbers. I'll read it to you. Negative 16 plus the quotient of a number and 2 is 35. So we have a couple of things going on here, a couple of clues. We see the word plus, so I'm going to put in an addition sign. I also see the word quotient, so I'm going to put in a fraction bar because the quotient is the answer to a division problem. And then I see the word is, and that means equals. Now we'll fill in the missing parts. Negative 16 plus the quotient of. Negative 16 plus, that means the negative 16 comes over here at the beginning. The quotient of a number, we'll call it x, and 2 is 35. Now we have moved from a verbal model into an equation, and now we have to solve it. We'll follow the same steps as before because we have two things going on with the x. It's being divided by positive 2, and there is a constant of a negative 16. Remember, our first step is to negate the constant. The inverse operation of a negative 16 is adding 16. So we'll write the expression that we have, negative 16 plus x divided by 2, and then we'll apply our positive 16 equals 35, and then again our positive 16. Over here, the negative 16 and the positive 16 cancel each other out, and we're left with just an x being divided by 2. When we add our positive 35 and our positive 16, we get a positive 51. And I'm going to move up here since I ran out of room. So we have x divided by 2 equals 51. The inverse operation of being divided by 2 is being multiplied by 2. So we're going to multiply both sides by 2 to keep the equation an equation. We want to make it fair, we want to keep it balanced. Here the 2's cross simplify, and we're left with just an x equaling 2 times 51 is 102. So the solution to our example number 3 is that x equals a positive 102. And we have 2 more examples, and they're both word problems. Let's look at number 4. 4 friends go out to dinner. Their bill is $128. They each have a coupon, and now they only need to pay $96. How much was the coupon worth? So believe it or not, we have all the information that we have in order to write an expression that we'll be able to solve to find out how much each coupon that the 4 people had was. So let's take a look at what we know. We know that their total bill was $128, so I'm going to start off with that figure. And we know that the $128 was made from 4 coupons that they had and the $96 that they had to pay. There are a couple of ways that we can do this. Here's one way to set up the equation. Another way would be to use subtraction. Maybe we'll do that after this. But here, just to review, their total bill was $128, and that was made up of the 4 coupons that they had and the $96 that their bill was. So the first thing we have to do is put a negative 96 on both sides. We want to get rid of our constant. We have 128 and our negative 96 equals 4c plus 96 minus 96. Over here on this side, 128 minus 96 equals 32. Our positive and negative 96 zero each other out. We end up with 4c. Now, remember, inverse operations. The c is being multiplied by 4. The way to get rid of it is to divide both sides by 4. We end up with a coefficient of 1. And we learn that c equals $8. Each person had a coupon worth $8. And as I said, there was another way that we can set up this equation. And I'll show you the other way. Now, the word total is used twice. We're talking about that their total bill was $128, but then the real final bill was only $96. So let's put 96 over here on the left of our equal sign. And how do we get that $96? Well, we took our original bill of $128 and we subtracted from it 4 coupons of some unknown amount. So we'll use the variable c. The rules don't change. Our goal is to get the variable by itself. Our first step is to negate the constant, which means we're going to put a negative 128 on both sides. So let's do that. 96 and a negative 128 equals 128 minus 4c, and then our negative 128. A positive 96 and a negative 128 make a negative 32. Over here, our positive 128 and our negative 128 make a sum of 0, and that leaves us just with negative 4c. Now we're almost done. Our c is practically alone. Right now, the c is being multiplied by a negative 4. Inverse operation means that we have to do the opposite of that. We have to divide both sides by a negative 4. Now over here, when we simplify negative 32 divided by a negative 4, we get a positive 8. Our coefficient here becomes a positive 1 because a negative 4 divided by itself is 1. C. So you see, both ways, we get the same results. The coupon that each person had was worth $8. And now our final example for the night. Our school had a concert and earned $525 in ticket sales. $349 of that is from students' tickets. Adult tickets cost $4. How many adults purchased tickets? And again, we have all the information that we need. We know here our total sales were $525. And there were two components that made up that total. The student sales of $349 and adult sales. Now, while we don't know how much money the adult sales brought in, we do know that each one was $4 a ticket. We want to know how many adult tickets were sold. Now that we have our equation set up, we're going to follow our steps. Our first step is to negate the constant. Our constant is a positive 349. Which means we have to put a negative 349 on both sides. When we simplify the left side, we have 525 minus 349, and that gives us 176. Over here, our positive 349 and our negative 349 together make a 0, and that leaves us with 4t. And you know by now, you could probably do this in your sleep. The t is being multiplied by 4, so we have to do the opposite of that. We have to divide both sides by 4. When we do, our t has a coefficient of 1, so we find out that t equals, and I'm not going to take the time, and I ran out of space to do this here, but in your books you will write out the long division of the 176 divided by 4, and you will get 44, which means that 44 adult tickets were purchased.